right, ready? Okay, so we're talking about, again, line segments. My stuff's flying away. Sorry. What does it say at the very top? Line segment what? Congruence. Okay, so we're going to talk about things being congruent. Different than equal. Okay, equal means exactly the same. Like, these are equal. They are exactly the same, right? Look exactly the same. These have the same length, but they're not the same, are they? Okay, so there's a big difference here. So for congruence with geometric figures, if two geometric figures have exactly the same shape, come on, I'm trying to make my pen work, sorry. The same shape and exactly the same size, then they are congruent. Same shape, same size. These are congruent. Right? Equal is referring to length. These are also equal in length, but they are congruent because they are the same shape and same size. Then they are what we call congruent. And, okay, so I was going to get ahead of myself. Never mind. Oh, actually, I don't have it in it. Oh, yeah, I do. Never mind. Talking to myself. Okay, if they have to be exactly the same shape and the same size. Could a line and an angle be congruent? No, a line and an angle are not the same. They're not the same shape. Two segments that have the same measure, which means length, are what we call congruent segments. Okay, they have to be exactly the same size and exactly the same shape in order to be congruent. Now, remember we talked about spelling, and we said that as long as we tell what it is, I'll take it. Well, in a lot of these words in geometry, we're going to have symbols for them so that we can use symbols rather than writing words. So for congruence, or something that is congruent, here's your symbol. It is an equal sign with a little squiggly above it. And that is read as congruent to. So if you ever are trying to say two things are congruent, you can use the symbol rather than writing the words. It's an equal sign with a little squiggly on top. That means congruent. So far, so good? Now, if I give you a picture and I want you to know that those are congruent and I don't tell you in words that they are congruent, I can use little tick marks on my segment. So if you'll look at your picture, do you notice that you have these? I'm going to highlight them a little bit more, but do you notice you have those little marks there in the middle of your segments? Those are the tick marks that show you that those are congruent segments. So if one of them is 1.7 centimeters, the other one is also going to be 1.7 centimeters. Okay, so those little tick marks on segments tell you that they're congruent without me having to physically say they're congruent. Is everybody okay with that? You're going to need to know that because we're going to give you pictures and I'm going to say, okay, what do those marks mean? If you don't know, then you don't know what to do with the question. Are we good? Okay. All right, let's take a look at the first example. We're going to go straight into some algebra. What's my big segment called in that picture from end to end? PR, okay? And then what is between? Q. Well, in this case, Q happens to be directly in the middle because do you notice those little tick marks on either of the smaller segments? That means that those smaller segments are congruent. So if I wanted to set up an equation and I wanted to solve for x, what would I do? Oh, they're congruent. Close. You have the right idea. Okay. What is PQ? What is the length of PQ? What does it tell you PQ is? 6x plus 20. Okay. In math, when we're talking about equations, if I tell you that two things are congruent, that means they have exactly the same length, yes? Exactly the same means what in math? Equals. So what we're going to do, you said congruent. Yes, they're congruent, but when we set up to solve for x, we need an equation. So without the congruent symbol, with an equal sign instead. We're going to take that and we're going to set it equal to, what is the other segment labeled as? Okay, so what I did is based off of these little markings right here, I know that this piece is the same as that piece. So in order to solve for x, I'm going to set them equal to each other. Keep going. Finish it. Solve that equation for x. 6x plus 20 equals 2x plus 6. You just have to be careful, especially when we put all this together. You can't always set them equal because you only know they're equal because of those two little tick marks showing that that's a... I'm going to try that one more time. Showing you that those two segments are congruent. A lot of the times we do the same thing over and over again, so we get in the habit of setting them equal, and then I will throw something in that is a little different. So you just have to make sure you're reading what it says. If I have the equation 6x plus 20 is equal to 2 parentheses x plus 6, what do I have to do before I can even start trying to solve this thing? I need to multiply the 2. I need to distribute. I need to get rid of those parentheses. So I'm going to have to take that 2 and multiply it by both the x and the 6. And so that's going to give me 2x plus 12. What'd you do next? The 2x or the 6x? Okay, so I'm going to subtract that 2x over to the other side. Again, if you need to draw that line on the equal sign to help you keep straight what's on one side and what's on the other, be my guest. Now what? So that's going to give me 4x equals negative 8. I'm going to come over here to the side because I'm running out of room. And then, and so what is x going to be here? Negative 2. When we're talking about lengths of segments, I don't generally like questions that ends up in negative, but because it's just x and not how long a segment is, it's okay. But if I were to ever ask you how long is PQ, is length ever negative? No. Okay, so just keep that in mind. If it's asking you for the length of something, we should never have a negative number. Here it's just asking you for x, so that's slightly different. Does everybody kind of understand? All right, let's take a look at that next question. I have segment, well, technically line CK. How do I know it's a line and not a segment? I got arrows on the end, okay? One thing that we need to understand, especially when I draw pictures, they're never drawn perfectly how they should be, okay? I'm not a robot, I can't draw it perfectly. So in geometry, things are never drawn to scale. So like in this particular question, G does not look like it's in the middle of CK, does it? Now, it could be, but I can't guarantee it is unless they tell me it is. They will either tell me in words that G is in the middle, or they will tell me with markings. The directions tell me anything about G being in the middle, or that CG is equal to GK or congruent to GK? Does it tell me that anywhere? No. Okay. What does it tell me though? Segment CK is how long? 174. So this kind of goes back to what we did yesterday. Then we would solve it a little differently. If G were in the middle, then I would be able to take the 8W plus 5 and set it equal to 5W. And then we could solve from there. But because I don't know it's in the middle, I can't set it up that way. Okay, so the whole thing is 174. So think back to what you did last night. If I wanted to find W,
we
add what? Add what parts? Plus, and that's going to equal. There you go. Okay, because this did not tell me that G is in the middle, or it did not tell me that CG was congruent to GK, I cannot set them equal. So you have to be very, very careful with the information they give you. You cannot assume with a picture that something is just because it looks that way. You have to be told in geometry, either with markings or with words. That's where people make mistakes. They're like, well, that looks like a 90-degree angle. Well, unless I tell you it's 90 degrees or I have a 90-degree marking, you can't assume that. And so in geometry, you cannot assume anything. You have to go off of what you were told, either in words or in the picture. Keep solving that equation. I want you to find W, and then we're going to have to do a little bit with that. With this equation, before I start moving things, I have some like terms I want to combine. What is 8 plus 5? Okay, so that's 13W plus 5 equals 174. Now I can start moving things to the other side of the equation, so I'm going to subtract 5. What is that, 169? Move over here. Then I'm going to divide by 13. Is 13? Oh, yeah, 169. Okay. Does everybody understand where 13 came from? Is that what you were asked for, though? No, what you were asked to find the length of CG. Remember, if it says find CG with no bar on the top of it, I want you to find the length of CG. How would I do that?
You substitute.
Yeah, substitute. Plug it in. What is CG represented as? 8 times W plus 5. So plug in 13. Do 8 times 13 and then add 5. That is the length of CG. 8 times 13, that's 8W plus 5. Did y'all get 109? Okay. And then for GK, I can just plug that in. 5 times 13. Or could I just do 174 minus 109? I could do that as well. Either way. But I'm going to go 5 times 13 just because I'm used to plugging things in. 65? Okay. Okay, so also keep in mind, once you get an answer, that doesn't mean you're finished with the question. You have to pay attention to what they're asking you for. Anybody have any questions? So far, so good? You guys see that number line there? Okay. So it's asking us to use the number line to determine if each statement is true or false. The first statement says that CE plus EH equals CH. What that means is the length of CE plus the length of EH is equal to the length of CH. How do I figure out how long CE is on that number line? Can I just count from C to E? Yeah, they're 1 unit apart, right? So just count. How many, is it from C to E? Look on the number line. Count from C to E. How many times do you have to go? 2. Okay, look at it. If I start at C, 1, 2, I'm at E. That means CE has a length of 2. Now count EH. How many times do you move to get from E to H? 3. Okay. And then you count from C to H. And we want to see if that makes a true statement or not. So start at C, count how many units you get to H. 6. Let's see. 1, 2, 3, 4, 5. Okay, yeah. Make sure you don't count where you start. That's not 1. You don't count 1 until you move. So does 2 plus 3 equal 5? Is that a true statement? Yes. All right, try D. Do the same thing. Count from 1 to the next and see if it makes a true statement. It may not. You either put yes or you put no. Count from D to J, count from J to G, and then count from D to G and see if that makes a true statement or not. Count from D to J, count from J to G, then count from D to G. Does that make a true statement? You're answering yes or no. How far is it from D to J? 6. Okay, 6. All right. How far is it, from J to G? 3. And then how far is it from D to G? 3. 2, 3, yeah. Does 6 plus 3 equal 3? No. Make sense? Okay. I just gave you your homework. I want to just talk to you about question number 2. Just make sure you understand what it's.
Is it always going to be adding?
Yes. Yeah. Well, because that said add, yeah. So DJ plus, see how it says DJ plus JG? Yeah. Look at number 2. Let me draw it real quick. Okay, you got the big segment X or WX. You got Y in between, and then you've got some markings, yes? Okay, and it's asking me to find the length of WY, right? What do these markings mean? That they're congruent. So how can I figure out what each one is if the whole thing is 8.8? You divide it by 2. You cut it in half. So what is WY going to be? That's what it's asking you to do. Does that make sense? Yeah, okay. 11 questions on your homework. You got plenty of time. You can get it done. That way you don't have to worry about it over the weekend. If you have questions while you're working, let me know. Very good.